Hi guys. I'll just wait for a couple of minutes, then we can get started. Yeah. So guys, I hope the questions of your contest were clear yesterday, right? I hope the contest questions were clear yesterday, right, everyone? Okay. Okay. So guys, today let's move on with revision of new topics, right? I hope you all know which topic we are going to pick up today. It is in I think the name of the meeting is that only, right? Yeah. So yeah, we'll get started. Let's just give a couple of minutes to the late joiners and then we can get started. Okay, so I'll get started now, everyone. Yeah, is my screen visible, guys? Yeah, I guess it is visible. कौन सा लिंक लिस्ट 2 फ्रॉम असाइनमेंट्स अच्छा ठीक है Mostly your linked list doubts will be cleared up. So guys, can you tell me which data structure that you find very easy to understand? Can you tell me the data structure that you find easy to understand questions? So you can think about stack, you can think about queue, you can say arrays, and you can say strings. But the easiest questions that come up are from trees and linked lists. You will get medium level questions from these two topics. And if you know pointer switching well, and if you know graph traversal well, you are you can solve more than 80% of the questions that can come on these topics. Any question on linked list is basically a pointer switching question. Do you agree on that? Right? So if you can switch the pointers, if you can imagine the flow in your head, how the switching should happen and which switch should happen first, then I guess you are good with linked lists already. And if you get a question on this, I mean, sometimes it happens in an interview that the interviewer asks which topic have you prepared well, which topic do you want me to ask a question from. If you say linked list, then it is most likely that even if the question is a medium level question, it's going to be straightforward and simple, and you should be able to solve it easily, right? Now, guys, I hope everybody is familiar with the difference between a linked list and an array, right? Right. What is the difference between linked list and an array? Linked list is a non-contiguous data structure, right? Linked list is non-contiguous, array is contiguous. What does that mean? That if you allocate an array, you first of all have to specify the size of the array beforehand, right? And if you allocate array, memory will be allocated in contiguous locations. So if this is ARR of 0, then the immediate next memory location will contain the next element, which is ARR of 1. Is this clear, everyone? Right? Similarly, if I consider a linked list, in a linked list, can I say that a linked list size is dynamic? Can I say linked list size is dynamic? Yes, a linked list can increase its size based on the number of elements the user wants to store, right? So let's say that I allocate a node and this particular cell has my node value. Okay? If I want to add another node, then this next node can be stored at some other memory location as well. And this variable will basically store the address of the next location. Is that clear? Right. Now, guys, again, I'll just repeat the same point. Linked list size is dynamic. If I have completely filled my array, is there any way to edit that array itself? Can I increase the size of that array itself? No, I have to allocate a new array and I have to copy the elements. But in linked list, that same case, I can just add a new node, right? Hannah, is this clear? So there is no concept of size in a linked list. I can increase and decrease the size dynamically as I want. Another difference is if I have an array and I want to insert an element at a specific position. If I want to insert 4 in between 3 and 5, I have to shift the elements like this. Do you agree? Right? But the same case is not true for a linked list. In a linked list, I can just say, if I have something like this, I want to insert a node 4, I will just remove this pointer and I will make the connection like this. Is this clear, everyone? Okay. Now, guys, let's just go through the different utility methods of a linked list and how the linked list data structure looks like. So Yeah. So guys, this is a linked list data structure. What are the, can you tell me what if I want to create a class node, what are the instance variables required for that? So it will be any data type and the data. Let's consider the example of integer data, and it will have the location of the next node. So that will be of type node only. It will have node next. Is this clear, everyone? So what is this? This node is basically example of a single linked list, right? This is the node of a singly linked list. Is that clear, everyone? Also, this linked list is also called vanilla linked list. Why am I calling it vanilla linked list? Because it does not have any kind of modifications. Whatever is a basic linked list, this is what it does. There are other linked lists as well, like doubly linked list and circular linked list. We will discuss them later on. Okay? Right now, we are focused on singly linked list. Is that clear, everyone? Okay. Now, guys, if I have a linked list class as well, if I want to create a class called linked list, right? Can you tell me the instance variable required for class linked list? There is the only requirement is the head node. Do you all agree with that? The only requirement to create a linked list class is the head node, right? So it will be of type node head. Is this clear? Now, guys, tell me, if my linked list is empty, what is the value of my head? It is null, right? So by default, it is null. Okay? Everybody clear on this? Right? Now, guys, can you tell me the utility methods required to manipulate a linked list? It is one utility method is insert, right? Other one is delete, right? Apart from this, I can have a utility method called size that will give me the size of the linked list. Something like this. Yes, reverse is also utility method. है ना? So these are my basic utility methods that I am going to discuss with you today. Yes, display also. Display is also very important because it easily gives you a pictorial representation of your linked list. Merge is not a utility method for the linked list class, at least. I hope this is clear to everyone, right? Okay. Now, guys, let's start and write the insert method first. Okay. Let's start and write the insert method first. So let's say I make this function called public. What should be the return type of my insert method, guys? What should be the return type? Do I need to return anything if I'm inserting? So I don't think that anything to be returned is required. So I can just make it void. Public void insert. What are the parameters that I want to take for inserting? I want to take the input of the data, right? So I will take int value. Let's call it val. Okay. This I am taking as the input. Now, guys, tell me what are the different cases that can happen. So if I am just taking the value as input, by default, where will I add the new node? By default, where will I add the new node? Can you tell me? If I'm taking only the value, I will add the new node at the end of the list. Do you agree? Right? I will add it towards the end, right? But since I am at my base case, so what is my base case right now? My base case is that the head is null. right? My head is null. So what is my base case? If the head is equal to null, what should I do, guys? If the head is equal to null, what should I do? I should create a head. Do you agree? I should create a head, है ना? If my head is null. So I can say head is equal to new node and I will pass the value. Is this clear to everyone? And I can return from here only. Is this clear, guys? Now, guys, if the head is not null, what should I do? If the head is not null and I want to insert towards the end, what should I do? I tell me in plain English, guys. I don't want to get the commands. Yes, exactly. I will traverse till the last node. Yes, exactly. So basically, I want to traverse till the end. Right. Now, I hope everybody is this much familiar with coding that if I say traverse till the end, you know how to traverse till the end, right? Because this is a revision module, we can consider everybody this much familiar with the concepts, right? So if I say traverse till the end, everybody knows I'm talking about a while loop. While temp is not equal to null, I will keep on moving forward. है ना? I will traverse till the last node and then I will just say that the last dot next is equal to the new node. Is this clear, everyone? Right. Now we are going to be modifying this insert function to handle more complex commands. What can be more complex commands than regular insert? More complex can be insert at specific position, right? Insert at specific position. है ना? So the user can basically pass me the index where the insert should happen, right? The user will pass me the index where the insert should happen. Do you agree with this, everyone? Right. So let's look at the code that we have. So let's take this up. So guys, this is the basic insert function. What is it doing? This is the base case. Base case where head is equal to null. So I hope this case is clear to everyone, right? Now, what is this thing? This is basically traversing till the end. Is this clear, guys? Right. And what is this part? This part is assigning new node to last dot next. Is this clear to everyone? Is the basic insert function clear to everyone? Anybody having any doubts on any line, just ask me now. Okay. So guys, let's move ahead. Now, guys, let's say that I want to insert at a given position, right? I want to insert at given position, right? And I'm just going to add a condition. Can you do it with tail concept? So what do you mean? That I am storing the tail as well of the linked list. Tail wala, it can get confusing for others, but tail का concept में क्या है? I just want to add it to the tail and I want to move the tail ahead, right? That is what it is. I hope that is clear, Shubh. Right? ठीक है? So inserting at specific position. ठीक है? Now I'm just giving a condition to the user over here that the position provided should be less than or equal to the last position available. Is this clear, everyone? Position provided should be less than equal to last position available. Why am I giving this condition to the user? So that my condition does not overflow. Is this clear, guys? So the overflow will be prevented. Do you agree? Right. So guys, just consider a linked list. Can you tell me if I'm doing array like indexing, which index is this one? It is 0. So I will also consider this to be position 0, right? This is position 1, this is 2, this is 3, and this is 4, right? Now, if the user is asking me to insert at position 3, what does the user mean? That the new node should be at position 3 after the operation. Is this clear, everyone? Excuse me. Right. So where should my insert go? I will create the new node here. I will make this pointer. And now this is my third position. This has become 4 and this has become 5. Is this clear to everyone? Right. Now guys, if my position provided is equal to 0, what do I want to do? I want to insert at head. Do you agree with this? Right. Okay. So guys, what can be the different conditions that occur? First of all, guys, tell me what is the loop, what is the function going to look like? Public void insert. What will the function take? It will take the node, it will take the value that I want to insert. So int value, and it will take int position. Is this clear to everyone? Excuse me. Right. Now, since I have the condition that position will not be greater than the available position, can I just use a for loop to traverse to the required position and make my switching? But can you tell me what is the edge case over here? What is the edge case, guys? The edge case is the insert at head. Do you agree? The edge case is insert at head, right? What are you saying? If position less than 0, position greater than size, not valid index. Yes, less than 0, that is not a valid index. Agreed. Yeah. Now, guys, tell me the edge cases for this one. Yes. So if the position is equal to 0, what should I be doing? I want to insert at head, right? If the position is 0, even if my linked list has a head, if the position is 0, I want to insert at head. So let's say I create a new node, right? I create this new node. Now, what do I want to do? I will say new node dot next is equal to head, right? And now I will say head is equal to new node and then return. Do you agree with this? Right. Now, guys, apart from this, can you tell me any edge case? Yes, I'll come to that, Vibhuti. 1 second. For now, the condition is that the index will be less, right? So that is why I'm not discussing. So see, this is how it's going to look pictorially. So if I have a linked list like this, right? I want to insert a new node at position 0, right? So this is basically my new node, right? And this is my head pointer. है ना? So I'm saying new node dot next is equal to head, right? And then I'm moving the head to the new node. Is that clear? So resultant क्या हो रहा है? Resultant हो रहा है this is becoming my head, right? And after this I am having my linked list. Is this clear? Mubarak. Clear है, right? So if you want to return new node, whenever you will insert, you will have to do head is equal to insert, right? This is not ideal. I just want to insert without doing that. Is this clear, everyone? सर ये लूप नहीं हो जाएगा मतलब see how the switching is happening. First I have my linked list. Let's say it only has two nodes, right? I will create a new node. This is my new node. I'm saying new node dot next is equal to the head, and then I'm saying head is equal to new node. So head is basically getting transferred here. समझ में आ रहा है? So basically in the new node, I am the new node का next is equal to head and head is equal to new node. इससे क्या हो रहा है? न्यू नोड का नेक्स्ट पॉइंटर में head is getting stored, which is this particular memory location, and then I am just moving the head back. Is this clear now? We'll just return from here. So I've added this return, right? Now guys, for the remaining cases, can I just use a for loop to traverse that many number of times? Can I just use a for loop to traverse that many number of times and insert at that position? ठीक है. Now guys, one rule of thumb, right? So let's say that I want to perform insertion at position 3, right? If I want to perform insertion at position 3, till which point should I traverse? Can you tell me? Yes. So whichever position I want to manipulate, I will traverse one position before that. So I will reach till this point, right? I will say my temp is equal to this, right? Then I will say, I will create this new node. I will say temp ka next. I will say temp ka next is equal to new node ka next, right? And then I will just remove this connection and place it here. Is that clear? So what is the flow? The flow is new node dot next is equal to temp dot next, right? Then I will say temp dot next is equal to new node. This is the order, right? So I don't have to save anything, है ना? I create the new node. I say temp का next, which is this, is equal to new node का next. Then I remove this connection and I say new temp का next is equal to new node, right? Is this clear to everyone? Everybody is clear with this, right? Okay. So this is my linked list, right? This is my linked list. I want to insert at position 3, right, Mukesh? I want to insert at position 3. Do you agree with that? So till which point will I traverse? I will traverse till the node just before the one that I want to manipulate, which is I am traversing till the node number 2. Do you agree? Right. Now what am I doing? I am creating a new node, right? I'm creating the new node. What is temp.next? Can you tell me what is temp.next? If I give values to this, temp.next is which one? It is the node with value 3, right? So I will say temp.next is equal to new node.next. So will this pointer happen? Will this pointer happen by executing this first line? Right. And after that, I am just saying temp.next, which is this particular pointer. I am just removing it from here and I am saying temp.next is equal to new node. Is this clear now? Okay. Everybody clear with insert at specific position, right? Now this same thing can be applied to the last node as well. है ना? So if I have a linked list that has size, that has position 0, 1, 2, 3, right? If the person says that they want to insert at 4, where will I traverse? If the user says they want to insert at 4, where will I traverse? I will traverse till this point, right? I will create a new node, है ना? Then I will say this is temp, right? So what is temp.next? Can you tell me what is temp.next? It is null. So I will say this next is equal to null, right? And then I will say temp.next is equal to this. Is this clear? So will this case work for the last node as well? So do I have to treat the last node as a edge case, guys? It is a general case only, right? सबको clear है? Insert at specific position. I think this is a question in your assignment also. So try to solve that now. Try to solve that after the class. Okay. So clear, right? Now guys, do you remember that I placed one condition on the user? I placed this condition on the user, right? That you cannot give me a position greater than the length of my list, right? Let's say that I want to remove this condition, right? So if I remove this condition, what will I do? I will just say that if the position that you give me, if that is greater than my limit, I will just add at the end. Is this clear? I will just add at the end if the position is greater than my limit. Is that clear, everyone? Can I do that? So guys, can you help me write the for loop to traverse till the k minus 1th node? Can you help me write that for loop? I will create a temporary node, right? Right. Then I will write a for loop for I is equal to 0. Till which point will I go? I will go till position -1. Yes, I less than position -1. So I am going till position -1, -1. Right? Let me write the entire for loop only. I less than position -1 and I plus plus. Is this clear? Now I will just say temp is equal to temp dot next. I will just say temp is equal to temp dot next, right? But guys, why did I leave so much space over here? Can you tell me? Who can tell me why is there space on top? पोजीशन होगा या पोजीशन -1? पोजीशन -1 होगा. Can you tell me, guys? Yes. No, not the base case. Not the base case. I just removed one restriction for the user, right? I just removed one restriction for the user. है ना? So I have to handle that case. If the user, let's say that my list was of length 3 and the user gave me position 6, if I keep on traversing, will I get null pointer exception here? Right. So what will I do? I will just write a condition if temp.next is equal to null, then I will break. Is this clear, everyone? So if I have reached the last node, then just break out of the loop. No need to traverse ahead. Is that clear? Everybody clear on this one? And now finally I just have to do my pointer switching, right? I will just create the new node, right? I will do new node dot next is equal to temp dot next, and then temp dot next is equal to new node. I hope this entire insert at any position is clear to everyone. Right? Everybody clear? Okay. So let me just show you the code for that. Insert at position. Right. So what is this, guys? This is the base case. Git का link कब देंगे? I will give you the link when we have discussed all the codes in this repository, right? So you will basically get it during the second or third week of the next month. Second week में मिल जाएगा. एक एक करके we will discuss all the data structures, right? So tell me, guys, this is the base case, right? So when the head is null, I will insert at head. Is that clear? Now this is the other base case. This is called insert at head case, right? So even if the list has values, I am inserting at head over here. Is this clear, guys? Are you clear on this? Right. Then finally, this for loop will traverse till position -1th node, right? Or the last node if position greater than length. Is this clear? And finally, this is my pointer switching. ठीक है? Everybody clear on this, है ना? ठीक है. Now guys, apart from insert, what is the second most important operation? What is the second most important operation? Deletion, right? So deletion is basically the second most important operation that I have to consider, right? So how do I know which node I want to delete? What will the user tell me which node has to be deleted? The user will pass a position to me, which position node they want to delete. Do you agree with this? The user will pass me the position, right? Basic, most of the time it is based on position, because you can have duplicate data also in your linked list, right? So if I have two nodes with the same value, then the program won't know which node to delete. So mostly it is position only. But yes, delete by data is also a valid function. And if you do delete by position, delete by data is going to be a piece of cake, right? So guys, what do I want to take as input into my function? Integer position, right? Now guys, can you tell me the base cases here? Base case, if head is null, then list does not exist, right? So I basically want to return. Is this clear? Right. Now guys, can I say that deletion of the head node is a special case? Can I say deletion of the head node is a special case? Yes. So if position is equal to 0, right? So let's draw that case also. So basically the target deletion is this one, है ना? So if the head is deleted, which node becomes the head? If the head is deleted, which node becomes the head? Head dot next. What is head dot next here? This, right? Now guys, consider the case that there is only one node, which is the head node. If I want to delete this, what becomes the head? Again, can I generalize it and can I say that head dot next will become the head? Can I generalize and say that head dot next will become the head because I have null already over here, right? So if the position is equal to 0, if the position is equal to 0, I will just say head is equal to head dot next and return. That is it. Is this clear, everyone? Right. Do you know about the Java garbage collector? Right. So in Java, values that are not being used by the program are automatically collected by the garbage collector, right? So if a certain memory location is not being referenced in the program, it will automatically be deleted, right? So if I just say that I have moved my head from this point to this point, so can I say that this pointer is basically useless now? Can I reach this point at in any way? Can I reach this node in any way? Do I have this node saved somewhere? It is not saved, right? So this is going to be deleted by the Java garbage collector. Is that clear? Is this clear, everyone? Okay. Now guys, tell me the other cases. So similar to the insert guys, if I want to delete, let's say I consider this list and I want to delete the third position, which is this one. No, let's say I want to delete the second position. Till which point should I traverse? I should traverse till position -1, right? So I will traverse till this point. Then what do I want to do? I want to basically eliminate this particular node, right? I want to eliminate this particular node. So I will say, I will just do this. Is that clear? So basically, I will traverse till this point. I have temp. I will say temp.next is equal to temp.next, which is this node, dot next, which is this node. Is that clear? Is this clear to everyone now? Excuse me. Right? Clear है? ठीक है. So let's write that. Same thing, same loop. Now, guys, tell me, if the position provided, if that is greater than the bounds, if the position provided, if that is greater than the bounds of my linked list, should I add a condition for that as well? If the position is greater than the number of nodes I have, I should not delete anything ideally. Do you agree with me? Right. So let's add a condition for that as well. So let's say that I add the for loop for I is equal to 0, I is less than position minus 1, I plus plus. What do I want to do? Temp is equal to temp dot next, right? I will keep on moving temp ahead, right? Now, apart from that, if temp dot next is equal to null, what does this mean? That I have reached the last node, right? If temp dot next is equal to null, this means I have reached the last node. I want to return from here, right? Because no deletion is going to happen. Clear? Now, guys, what do I want to do? I will just say temp dot next is equal to temp dot next dot next. Is this clear, guys? So I want to delete a specific position, right? I want to delete a specific position. So I cannot use a while loop, because while loop के लिए या तो the condition has to be related to the position rather than temp not equal to null. I hope you understand that. Clear है सबको अभी तक? Right. So let's just give you an overview of the code for delete as well. ठीक है. So what is this part? This is the base case, right? This is delete head, right? Then this part is what? This is delete any, right? And finally, this is the last block, which is pointer switching. Why have we added this condition? Let's check that once. So let's say that, yes, so let's say that I have reached here, and this, let's say the last one wants to be deleted, right? Let's say I want to delete the last position. So temp dot next is equal to, if temp dot next not equal to null, right? So but this condition is going to fix that anyway. So if temp dot next is null, I'm returning anyway. So this is not required. Okay, is this clear, everyone? Hello. Now tell me, guys, can you quickly write the display function for the linked list? Can you quickly write the display function for the linked list? What is the display function all about? It is just going to be a simple while loop. Yes, basically print, display, print, print list, anything. All this is just going to show me the current status of my linked list, how it is looking like. Yes, exactly. So I will never switch my head pointer. I always use a temporary pointer for pointer switching. So while temp is not equal to null, I will print the current value and I will move it to the next one. Is that clear? So let me just show you, but I think I have done something better in my print function. So let me just excuse me, ll. So I've created this linked list class. Okay. Then I will do list dot insert. Let's say 10, right? Then list dot insert, let's say 20, and list dot insert, let's say 30. And now let's do list dot print list, right? So let's say guys that you were given the task to implement a linked list in an interview. Okay. So print list function likhna is important, right? But how can you enhance the print list function? You can enhance it by adding these arrows, right? So how is this important? This gives a proper representation in a list form, right? Excuse me. Yeah, guys. So I hope this is clear to everyone. So which methods can I consider to be clear? Insert at any position is clear and delete at any position is clear, right? And display is also clear, right? Now, uh, let's do that question which involves the fast and slow pointer. Let's do the find middle of linked list, right? So guys, there are two ways to find the, yes, I'm coming to reverse. Yes, we'll do reverse here. There are two ways to find the middle of a linked list, right? Can you tell me the inefficient way, guys? So the inefficient way, if I want to write the code in English, what will I say? The inefficient way to find the middle of a linked list is to count all elements, right? Then traverse till middle. Is this clear, everyone? What is the complexity for this? It is big O of this will take n and this will take n by 2, right? So 3n by 2, it is basically big O of n, but you can see that it is taking more time, right? It is taking more time. The efficient way is to use two pointers. One pointer you can say fast, you some people also refer it as hare, and the other one you can say slow, some people refer it as tortoise, right? Yes. So in this, what will I do? I will have a linked list like this, right? I will start both my pointers at the same position, slow and fast, right? And I will iterate this. I will iterate while fast dot next is not equal to null, right? I will iterate while fast dot next not equal to null. Okay. So after the first iteration, where will fast go? Can you tell me? Fast will go to the next, which is this one. Where will slow go? Slow will reach to the next position, which is this one, right? Now in the next iteration, fast will reach this point and slow will reach this point. Now, can I move the fast ahead? Can I move the fast ahead anymore? No, I cannot move. So the slow is basically my middle. Is that clear, guys? Yes, coming to that. Now, you will know that I want to modify a certain condition in my while loop. I want to modify a certain condition in my while loop. So let's take even number of nodes, right? So fast and slow start from here. Then fast comes here, slow comes here in the next iteration. Now after this, fast will come here and slow will come to this point, right? But can I say that both of these nodes are the middle of my linked list? Can I say both of these nodes are the middle of my linked list? Yes. So my while loop condition will be modified like this. While fast dot next is not equal to null and fast dot next is not equal to null. I will say slow is equal to slow dot next and fast is equal to fast dot next. Is this clear, everyone? And towards the end, I just want to return slow dot val. Is that clear, guys? Sometimes they ask to find the right mid element. So अगर right mid बोल रहा है तो just return slow dot next dot val. This is the right mid. So this is the best loop. Why? Because if you have reached this node, then you can either return this or return this. Returning both is possible. But if you go here, if your slow reaches this, then you cannot return the left mid, right? You can only return the right mid if you have gone to the right mid. है ना? Do you agree? No, it will be a and condition, not a or condition. ठीक है, middle of the linked list. Is that clear, guys? Print from middle till end. So you have reached the middle. You have reached the middle. Now just do display from slow. So display को एक node input दे दो और वो display will just print till the end. हो गया. Is this clear, guys? ठीक है. Let's move ahead. So what is the next one? Next one is our reverse. Right. Cycle detection we will do in some in some classes. Linked list is going to continue for 2-3 classes. Cycle detection and some other questions are also part, so we will do them, right? So reversing a linked list, guys. So if I have a list like this, what is the desired output of reverse? Do you agree with this? right? ठीक है. Now guys, reversing का there are two approaches. Which one do you want me to explain? अच्छा ठीक है, let's do both. So one is the basic stack approach, right? Your iterative approach is your basic stack approach. What do you do in that? You start traversing from this point, you insert the node, you again insert the node, and you again insert the node, right? Now you cannot traverse. Then you pop out from the stack and you create the list like this, and then you return this new list. Is this clear? This is the basic iterative approach. Clear to everyone? Right. Now guys, iska recursive approach. So if I want to approach any recursive problem, what should I think about first? The base case, right? Can you tell me the base case for reversal here? Base case is that there is no node at all. So if there is no list, is any reversal required? If there is no list, is any reversal required? So basically n is equal to 0. No reversal required, right? Right. Now if I have n is equal to 1, so my list is just this. What will be the reverse form of this list? What will be the reverse form of this list, guys? Same, right? So basically no reversal required. Do you agree with me? Now comes the interesting cases. N is equal to 2. So I have two nodes. What will be the reverse form? It is 2, 1 and n, right? Do you agree with this, everyone? Now, if I have n is equal to 3, what is the reversing? Right? Do you agree with me here? Right. So, guys, can I say that if I have a list of length, let's say 3, if I have a list of length 3, and now let's say that I do one thing. I say I put 3 over here, and I say 3 ka next is equal to this. Now, can I say that the previous part, only this part of the list is reversed already? Can I say this is reversed? Can I say just this part of the list is reversed? And can I call recursively the same function here? Tell me, guys. Right. So after this, what will be the next case? Same thing will happen. Now, since the same thing is getting called recursively on this list, 2 will come here and 1 will come here, and this will be null. Now I will call the same function recursively on this part. And what is this? This is the base case. Right. So what do I want to do, guys? I want to perform my pointer switching in such a way that this particular result is observed. Do you agree? Do you agree here, guys? Right. Now let's write the function, guys. Let's write the function. So public node. So the return type is node for reverse. Keep yourself muted, guys. Public node reverse. What will it take as input? Let's say it is taking node head. Right. What do I want to write here? What are my base cases, guys? If my head is null, or if the head is the only element, can I say that is my base case? Right. So if head is null or head is only element, what do I want to do? Return head. Do you agree here? So this is out of the way, right? Apart from that, guys, what do I want to do? I want to recursively call the same function on the remaining part of my list. Do you agree? I want to recursively call the same function on the remaining part of my list. Do you agree here? Right. So let's draw the diagram. Okay. So let's say that initially my list was this. Okay. Initially my list was this. Do you agree? Now recursively, the same thing was called on which part? What will I call my method on? I will call it on head.next. Do you agree with me? I will call it on head.next, right? So let's say, guys, let's say that my recursive call happens like this. Now, is this a base case? Is this a base case? Okay. So what is the return of this particular method call? What is the return of this particular method call? It is this list. So let's say, please keep muted, guys. Please keep yourself muted. So the return type is this list. So let's say I say X is equal to this particular list. Okay? X is equal to this particular list. This is what I'm saying. Is this clear so far, everybody? Right. Now, what do I want to do, guys? I want to place this 2 ahead of my head. Do you agree? Right. So, where is my head right now? My head is over here. Hai na? And what do I have in my X variable? My X variable is basically just this part. Is this clear? So guys, where do I want to shift my head? Can you tell me? My new node will be my head. Can I say that? My new node will be my head. So this is my desired head. Do you agree with me here? This is my desired head, right? So करना क्या है यहाँ पर? पॉइंटर स्विच कर रहे हैं. Head dot next. Okay, so basically I should have X dot next is equal to the head, right? I should do X dot next is equal to the head, right? And also I want to say head dot next is equal to null, है ना? Something like this. Do you agree with me? So if I say 1 dot next is equal to null, then this becomes null and iska next becomes 1. So I have 2, 1 and this. Do you agree? Is this clear, guys? Okay. Yes, yes, yes. Repeating. Okay. So, yeah, okay. So let's say that my initial method call is for this. Okay. Let's say my initial method call is for this. So far, are you clear on that? Right. Now, what will the method call be after this? It will call for this. Do you agree? Right. And this will call for what? It will call for 3 and null. Do you agree here? Right. So what is the return of this one? The same thing will be returned to this, right? So x is equal to 3 and null will be returned to this, right? Do you agree? है ना? Now, what is my goal? What is my goal? I want to place the head after this to the end, right? I want to place the head at the end of x, right? So I want to place head at the end of x. Do you agree with this? And after that, I want to say that x is the head and return it. Do you agree? Right. So if I return 3 and n from here, what will be returned from here? 3 will become the head, right? 3 will become the new head, and I will place the head at the end of this, and this will be null. Do you agree? And after this, the return type from this will be 3, 2, and 1 will be placed at the end of x, and this will become the new head. Is this clear, everyone? Clear hai, guys? Everybody followed this, right? Yeah. So guys, one thing, if I write my program, let's say the base case is handled here. I will store x is equal to reverse head dot next. Do you agree? Because I'm calling the function recursively on the remaining part, है ना? And I'm storing it with x. Do you agree? Right. Now, what do I want to do with x? Can I say that x is basically my new head? In the current iteration, x is my new head. Can I say that? right? So can I just return X? Why will I return X? Because the reverse is called like this. Head is equal to reverse head, right? The reverse is called like this. So can I return X in the end? And what do I want to do in the middle? Which part do I want to handle in the middle? Placing the head at the last. Do you agree with this? Everybody clear so far? Can I say that I want to do head dot next is equal to null? Can I say that I want to do head dot next is equal to null? Because this one is going to the end. So this null will always come. Do you agree with me? Right? So what can I write to transfer my head to the end? What can I write to transfer my head towards the end? Can you tell me what do I want to write to just shift my head to the end of X? Who can tell me? Yes, exactly. Head dot next is equal to head. Who wants a dry run? Okay. Yeah. Okay. So let's do one thing better than a dry run. Let's do something better than a dry run. Let's print the intermediate lists, right? Let's print the intermediate list in my recursive calls. So linked list kholo, and I have my reverse method here, right? What will I do is I will just add a print list method in every recursive call. So print list, okay? So will this print my list in every recursive call, guys? Right? So let's just do list dot reverse and let's pass it the head, which is my list dot head. And I have to do list dot head is equal to this. Some other problem. Did the reverse work or not? Yeah, reverse worked, but I think it did not get printed. So let's move this. Let's move this over here. Yes. So now you can see how the reverse is happening. Iterative method, recursive method में you are using the system stack, and iterative method में you are using the data structure, stack data structure. So does it make a difference? Because the system stack, you are also using space in the recursive method. So if you do using stack, the easier method is this because it is easy to understand, right? but either way you use the system stack, so the recursive one is faster. Without stack, can we just print after recursive call? We can use previous variable as well. So if you have a previous variable along with the next, so that is a doubly linked list, right? You will always have to maintain the previous variable and you have to iterate multiple number of times if it is a singly linked list and you want to do without stack. So in order to explain this output, first, let's see what happened here. Excuse me. So the initially I called 10, 20, and 30, right? Everybody agrees. This was the initial list that was passed, right, guys? Then what happened? Is this condition true? Is this condition true right now? No. So where will I do? Where will I move? I will move to this condition. What is this new node? Let's say this is X only, right? Let's consider this as X only. So again, another call is made for head dot next. What is head? Current head is this. Do you agree? So head dot next के लिए call हो रहा है 20 and 30 and null. Is this clear? Why are you saying no, guys? Did I ask something? So far, everybody following? Right? Then after this, what is the new call? What is the new call? I'm saying X is equal to this, right? What is the new call after this? It is calling for just 30. Do you agree? Head dot next के लिए call हो रहा है. This is the current head, right? So it will be called for this, and this is what is getting returned. Do you agree? So my X is equal to 30 and null, right? My X is equal to 30 and null, and my head is equal to 20 right now. Head is equal to node 20 in this particular iteration I'm talking about. Is that clear to you? X is equal to this, and my head is equal to head is at 20. Is this clear to you guys? Now, guys, what is my head dot next dot next? Can you tell me what is head dot next dot next? So if I say this is the head, next dot next is becoming null. Some problem with our dry run only. Let's start off once again. One second, guys. So over here, my X is becoming, new node is becoming 30 and null. Then I am saying head dot next is equal to the head. And finally, I'm saying head dot next is equal to null. Okay. So problem with, is the code working? Let's add a few more values. Yeah, code is fine. So where did we go wrong in the dry run? Let's see. Yes, right. So what is happening? My head is at 20, right, guys? So what am I doing in this particular step? I am saying 20 ka next is 30 and iska next is what? Null, right? So I am saying this particular point 30 ka next is becoming the head. And what is the head node here, guys? The head node here is 20. समझ में आया? The head node here is 20, right? And then when I'm saying head dot next is equal to null, this pointer is getting removed, right? And finally, this was already X and this is getting returned. Is that clear now? Is this clear, guys? How many are still a little confused over here? Okay. So guys, whenever I draw a circle around a value, just consider that to be a node, right? So what is my head, guys? What is my head? My head is node 20, right? My head is node 20. Is that clear to you? My head is node 20. Do you agree? Right. Now, head dot next 20, 30 and null. What is head dot next? This is head dot next, right? Let's say that this is value y. Okay. Now, if I say head dot next, can I also say y dot next? Can I also say y dot next? Instead of head dot next, can I also say, guys, y dot next? So I am saying y dot next is equal to the head. So y dot next is equal to node 20. Is this clear? Y dot next is equal to node 20. And finally, I am saying head dot next is equal to null. So basically, I am removing this pointer and this is gone. Now, what was this? What was this? My X was also pointing over here, right? So I'm returning this thing. So can you see that this part of the list is reversed? Is this clear now? Is this clear, guys? Clear है? Recursive reversal is clear to everyone? Head dot next to new node dot next. Yeah, that should also work. Let's try. But I think it will not work for other cases, right? It won't work for cases that is greater than 4. So reversal is clear, both recursive and iterative, right? Guys, is reversing also a part of your assignment? Okay, so I think most of the assignment questions are done, right? So one was your find middle, right? Was this assignment question? And reversal is done. Now there is another question, reverse part of linked list, right? So basically you have a linked list like this, and the person is asking you to reverse from this point to this point, right? So guys, since I've explained you reverse today, I want you to practice this one by yourself, and we will discuss this reverse part of a linked list in the next class. इसके अलावा is there any method that I can show you? Yes, there is one question also that is important, which is yes. So yes, Vibhuti, this question that I'm doing is quite similar to the one that you are asking. So this question is remove kth node from the end of the list. Remove kth node from the end of the list. So if I have a list like this, and the question is saying remove second node from the end, which node should be removed? Can I say this node has to be removed? Right? So this is also a very important question, and there is a very simple way to do it, right? There is one way to just count, right? And then just do count minus n and remove, right? This is the simple one, but there is a longer approach. There is a much better approach as well, which will take less. It will, this approach is also big O of n, and that is also big O of n, but this, the other one that I'm talking about, is a little more optimized. So I want you to try this by yourself. This is also a part of your homework question. Let me just take one homework question. I'll just post the homework question on the doc now. So this is it for the linked list introduction, guys. Yes, that question is also part of the your lesson plan, Shubh. So we will be taking that up in upcoming classes. Okay. So guys, I think we are mostly remove kth from end of the list. Sir, please tell about inbuilt method for linked list that was not discussed in previous module. Acha. So linked list is basically a class that implements the interface queue. Okay. So let me just go to the linked list. Yeah. So this is your linked list class, guys. This implements the interface queue. You can see this implements your DQ, right? Double-ended queue, and double-ended queue basically implements extends queue. Is this clear? So I don't know if you know, but an interface can extend another interface, right? So your linked list is basically implementing the DQ interface, and the DQ interface is extending the queue interface, right? So it is looking something like this. Is this clear to you now? Right? Then linked list, you have certain inbuilt methods. So if I just create my linked list object, then I can access the methods. So I can do L dot, and there is a object, there is a method called size. So you know what is size. Size will return the size of the linked list, right? Now this method clear. I think everybody can understand by the method name that this will delete all the elements of the linked list, right? Now remove last, very self-explanatory. It will remove the last element. Remove first. This is also self-explanatory. It will remove the first element. Then get last. It will get the last element. Is this clear, Vibhuti? You guys, I highly suggest you guys to install Java compiler on your local machine, install VS Code, and view the documentation of the data structures that you're working with like this. So reverse in between ka approach. So see, since you have reversed an entire list, so can I say, if I just want you to reverse this part, can I say this part is also a list? Can I say this part is also a list? If I want to reverse this part is also a list. So can I just call the reverse on this part? I can say 1, and this got reversed internally, 2, and I have 4. Now I have to assign 2 pointers. I want to say 1 ka next is equal to the new head, and 2 ka next is equal to the tail of my actual list. Is this clear? So zyada, the logic is not that much. You just have to reverse that part and connect the 2 outer pointers. Is that clear to you? Think about how the pointer switching is going to happen here. You are going, just try to linked list practice करने का best तरीका is to simply do it on pen and paper. So easily हो जाएगा. Clear है? Tell me guys, what else are you having doubts with? Linked list dot. Now you can add any element, and you can see that it is taking the, I have 2 add functions. One add function is just taking the integer, so it will add at the end, and the other add function is also taking the index. Where do I want to add it? Is that clear to you? So what is the second add function? It is basically insert at specific position. Is that clear? Now I have this another method, add first. What will it do? It will add at the first location. Add last will add at the last position. Then equals will basically check for equality. Get will give you the particular element at a given index, right? So these are quite simple. Is empty will basically return if the linked list is empty or not, similar to a stack. I hope it is clear to everyone. Then you have the different remove methods. Remove any particular value, remove at any particular index. What happens if we create array list and we want to add new element to it? Will it get added to the array list, or new array list will get created? So are you familiar with how an array list works, guys? Are you familiar how an array list works? How is the array list size dynamic? How many of you are not familiar with that? Not familiar. So I see a couple of people are not familiar. So array list internally use an array only, right? So let's say that array list, you created an object of type array list, and internally the array list allocated an array of size 5. I'm just giving you an example, right? The size does not have to be 5 always. Okay. Now let's say that you filled your array list completely, right? Now when you try to add the next value, the array list will allocate a new array of bigger size, and it will copy the elements to the new array. Is that clear? this is how the size of the array list is dynamic. Is this clear to you? So so the interviewer will ask you that array list matlab tell me how an array list works, right? So you will tell them that the array list works like that. But there is a very good counter question on this one, right? The person will tell you to implement a never ending stack, right? So you have to implement a stack that will never overflow. How will you do that? Anybody has any ideas? You have to implement the stack using arrays, right? And the stack should never overflow. So that is the very simple solution, but I am telling you, you have to implement it using arrays, right? So iska ek counter question hai, you just implement the stack using an array, and the moment the stack is getting overflowed, you allocate a new array of bigger size and you copy the elements. Similar thing to your array list. Yes, so you will increase the size of the array, which means you will allocate new array and you will copy. Is this clear? Now, the person will say that the top element, only the top element of the stack is accessible, right? Can you access any other element of a stack apart from the top element? No, right? So you have to make sure that you only access the top element. So how will you shift the elements? Can I shift the elements from this point? No, I can only shift the elements from the top and I will go back like this. Is this clear? So these things just keep in mind. So even if you are implementing the stack using an array, even if every element is accessible, the stack has certain rules. The stack will, in a stack, ideally you should not be allowed to access the other element. Similar thing in a queue, you will not be allowed to access any element apart from the front and rear. Is that clear? Okay. So tell me guys, we have some time today. I can take some, I mean, if you have any doubts that can be explained quickly, I'll just add to linked list is a part of our question. Combination sum 2 is getting TLE. Okay, let's just write that down. Combination sum 2. So I have the hash set. Let's run this. This is the previous solution only, I guess. Let's submit. It got accepted here. Which one are you using? Is it this one or is it a different one? Combination sum 3, have we done it in class? So if I run this, let's see. Accepted, submitting. Yeah, this also got accepted. You want the code for this? Yes, we will be discussing oops in some time. Abhi linked list aa gaya na beech mein. So we'll be discussing oops after that. Uh, where is combination sum? So this is, I think this is the three combination sum three, right? Yeah. And combination sum two. This one. Yeah. I've added it, guys. So you can try with this one. Also, I strongly suggest you guys, instead of asking me to update the code, you guys are also pretty competent now that you can attempt it by yourself. Try to find out why that code is giving TLE, right? Instead of using the code that I just shared, try to find out why is it giving TLE and try to solve it yourself also. Okay? Is everybody clear so far? सर इस मंथ में कब तक और क्लास चलेगी? इस मंथ पूरी क्लास चलेगी एंड फ्रॉम नेक्स्ट मंथ आई थिंक लास्ट वीक you will have some mock interviews, rather you will have the module clearing interview. I think after that you will either go to module 4 or you will go to the backend module. What is the meaning of 3 killed in line 3? Where? No, for the this is a 2 month module, right? So इसमें बीच में I don't, मतलब you can have a, I think you will have that um normal mock, but not something. Where do I have 3 killed? What do you mean? So I get this while solving problems. Where do you get that? No, where do you get that error? Tell me. Portal. I don't know about the portal. Yes. Portal ka doubts don't ask me. What are good VS Code extensions? Acha. So VS Code ka extension, you can see the extension that I have. I have this Dart extension. So I program in Flutter. Flutter uses this programming language called Dart. So I have this debugger for Java. So this is from Microsoft. Then I have this extension pack for Java. It has all the important extensions in one pack. Then this Flutter. So I use this for my app development. Then I have Git lens to track the commit history, and this IntelliCode, and these are basically these basically provide you with assistive scripts that you can use. Then this Jupyter notebook is for my Python machine learning and other stuff. I mean, I write some Jupyter notebooks for data analysis and all. So this is used for that. Then this Maven for Java is for, I think it is for Gradle. Gradle, or I don't remember which one is that. Then again, I have Python. This synthwave, acha, this is a theme, right? This I installed this theme, but I did not like it. Then I have this VS Code icons. So this is also a theme. So you can see that all my files have this pretty icons. So this is what this does. Okay. So you can try Panda theme for VS Code. ठीक है, I'll try it later on. This one. It looks the same to me. Dark syntax. The comments are very light. No, I'll keep my default. Is there any separate class for strings? Yes, definitely. So every string is an object. So if you go to the definition of a string, you can see it is a class, public final class string, and it is implementing these classes. It is implementing these interfaces. और बोलो guys, any other doubts? अच्छा, okay, that class. Strings का there is no separate class as of now, but there are certain questions specific to strings that we are going to be discussing. So strings का there are 2-3 more questions that are good questions and that are company asked questions. So अपना module D का I think last week में यही होगा. We will just be doing a mixed bag of questions, picking up any random question and figuring out how to solve it, what data structure to use, what algo to use, all those things. ठीक है, everybody clear? Right, any doubts regarding today's session? Let me share this PDF as well. So if I add more functionality to a snake game, then is it good for minor project? You can say that snake game is a minor project. Just make sure that it is not repetitive, right? It should not look that.
हेलो, आई एम ऑडिबल सर?
हाँ बोलो.
सर मुझे बस ये एक क्वेश्चन है, इसमें बस नॉर्मल से टेस्ट केस हैंडल नहीं हो रहा है एच केस कि अगर पोजीशन 0 है तो कैसे ऐड इंसर्ट अ नोड स्पेसिफिक पोजीशन इन अ लिंक लिस्ट.
हाँ, वो क्वेश्चन तो हम लोग ने किया ना अभी.
हाँ सर वो किया, बट उसमें मैं सारा कर चुका हूँ, बट एक टेस्ट केस नहीं चल रहा, बट अगर पोजीशन 0 है तो.
Wait 1 second. Let me just upload this.
बस सर यही नॉर्मल से एच केस बता दो यहीं पर चाहे हो तो.
हाँ बोलो, कौन सा एज केस नहीं चल रहा है? व्हेन पोजीशन इज 0.
0, यस सर.
एंड यू आर ट्राइंग टू डिलीट, राइट?
यस सर. नहीं सर, इंसर्ट. इंसर्ट
तो इंसर्ट का तो अपने लोगों ने लिखा था ना, insert at position. So if position is 0, insert at head. We have this case. So you can just add this case, special case, and then return from there.
हाँ सर, ये क्या बोला है कि अगर पोजीशन 0 है तो न्यू नोड वैल्यू के नेक्स्ट में हेड डाल दिया एंड हेड में न्यू नोड एंड रिटर्न. एंड सर ये लास्ट में नीचे आके क्या करा, नोड टेम्प इज इक्वल्स टू हेड, क्या चाहिए स्टोर करा लिया टेम्प में.
नोड टेम्प इज इक्वल, देखो अगर पोजीशन 0 है ना तो यहीं पे तुम्हारा फंक्शन टर्मिनेट हो रहा है, तो यू डोंट हैव टू बॉदर अबाउट दिस.
ओके सर, बस मतलब इतना ही करना है मुझे कि अगर, ओके डन।
ठीक है,
ये थैंक यू सर।
चलो ठीक है गाइस, लेट्स एंड द क्लास अर्ली टुडे। सो
हेलो सर,
मोस्टली
सर कल,
मोस्टली
कल किस
implementation
टाइम
of
है?
mostly
कल क्लास है
implementation of
मॉर्निंग में?
mostly implementation of doubly and circular linked list is only going to be asked. उसमें से you don't get much questions. There are one or two questions on lead code that we can take up on doubly linked list. Circular का I don't feel like I have seen any questions. हाँ, who was speaking?
सर कल मॉर्निंग में क्लास है, किस टाइम से?
मेरा तो क्लास नहीं है भाई, मेरा
नहीं अभी
मॉर्निंग
आप
का
कह रहे हैं ना लेट्स सी मॉर्निंग क्लास।
व्हाट?
अभी आपने बोला कि सुबह मतलब मॉर्निंग क्लास में मिलते हैं।
नहीं नहीं, I never said that. Did I say something like that?
आई थिंक
Guys,
माय मिस्टेक, आई थिंक, सॉरी सर।
cycle detection we'll do. Yes, cycle detection is a part of our lesson plan. So we'll do that. ठीक है guys, let's end the class early today. 3 minutes early. So I'll see you tomorrow. Good night. Bye bye.